What's at the center of a black hole? Well, black holes are some of the most mysterious objects in the universe, and they have two key parts, the event horizon and the singularity. The event horizon is the point of no return. Once anything passes it, not even light can escape. At the very center lies the singularity, a point thought to be infinitely small and dense where all the laws of physics break down. But does the singularity really exist? Maybe not. Some theories suggest other possibilities. One idea is the Planck star, which comes from a theory called loop quantum gravity. In this theory, space and time aren't smooth. They're made of tiny discrete chunks. This chunkiness prevents matter from collapsing into an infinitely small point. Instead, when a star collapses into a black hole, the matter could be compressed into a tiny but finite-sized object, as small as the Planck length. Over time, the intense gravity would cause this matter to uncollapse in a massive explosion, but because of time dilation near the black hole, this process could take billions of years, so we won't be seeing any black holes exploding soon. Another idea is the Gravastar, which replaces the singularity with dark energy, a mysterious force that causes the universe to expand. In this scenario, the inside of a black hole is filled with dark energy, so matter never fully crosses the event horizon. It just hovers near the edge. But here's the catch. Recent data from gravitational wave detectors like LIGO suggest that gravastars probably don't exist. When black holes merge, the signals they produce differ from what we'd expect from gravastars, making them less likely. A rotating black hole doesn't have a single point singularity, it has a ring-shaped one. The spin of the black hole creates such strong centrifugal forces that parts of it act like anti-gravity, leading to something called the inner horizon. If you cross this boundary, you'd be hit by all the energy and radiation that ever fell into the black hole, all at once. This is what makes rotating black holes unstable according to our current math. What's really happening inside a black hole? We don't know, and we might never know. But these exotic theories offer a glimpse into the strange possibilities lurking in the depths of the universe.